In this video, we are working through lesson 7.5, and this video is going to deal all with trapezoids. So we're going to be working through problems 2, 4, 5, and 6 on page 219 in your student journal. Before we do that, just a couple things to remember. A trapezoid is a quadrilateral where one pair of opposite sides are parallel. And we call these sides the base. There's two bases in a trapezoid. The other two sides are called the legs. Now, there's a special type of trapezoid called an isosceles trapezoid. And this is a trapezoid where the two legs are congruent. And we learn about a bunch of different properties that isosceles trapezoids have. And these properties are at the bottom of page 217 and on page 218. And so we'll be referencing these different properties as we do some of our extra practice. So we are going to go ahead and turn to page 219 in our student journal, and we're going to start with number 2. Okay. In number 2, it asks us to find the measure of angle K and the measure of angle L. In this particular quadrilateral, notice this is a trapezoid. There's one pair of opposite sides that are parallel. It's also an isosceles trapezoid because these two legs are congruent. So all the properties of isosceles trapezoids apply. One thing we know about isosceles trapezoids with their angles is that each pair of base angles is congruent. So this pair of base angles, they would be congruent to each other, and these base angles would be congruent to each other. You also know that consecutive angles, so for example angle C and D, they're supplementary. They add up to 180 degrees. This is going to help us find some angles in number 2. So in this isosceles trapezoid, angle M, this base angle, and angle L, those are a pair of base angles. You know that base angles are congruent in an isosceles trapezoid. So if the measure of angle M is 23 degrees, the measure of angle L is also 23 degrees because they are congruent. Now, to find the measure of angle K, I do not know angle J, so I can't use angle J to help me find angle K. So I can't use these base angles. However, earlier we stated consecutive angles, so angles that are next to each other that share a side, that are not base angles, they're supplementary. They add up to 180. So angle L and angle K must add up to 180 degrees. So to find the measure of angle K, I simply need to take 180 and subtract 23 degrees from that. And when I do that, I discovered that the measure of angle K is 157 degrees. Now we're going to work through number 4, 5, and 6. Now all of these problems have to deal with the mid-segment theorem of trapezoids. And so before we work on 4, 5, and 6, let's remind ourselves what the mid-segment theorem is. The mid-segment, the segment that bisects the legs, is going to be half of the sum of the bases. So what this means is the mid-segment, so in this case, the length of MN, will be equal to 1/2 the sum of the two bases. So our two bases in this picture are side AB and side DC. If we were to take the length of AB and add it to the length of DC, and then take half of that or multiply it by 1/2, we get the measure or the length of the mid-segment. So this is the formula we're going to be using when we work with mid-segments of trapezoids. So in number 4, we need to find CD, the length of CD. And number 4, the length of CD is our mid-segment. So let's use our mid-segment formula. Our mid-segment, in this case, the length of CD, will be equal to 1/2 the sum of the bases. Well, the length of this base is 12, and the length of this base is 36. So all I need to do is add those two lengths together and then multiply it by 1/2. 12 plus 36 gets me 48. And 1/2 times 48 is 24. So the length of CD is 24 units. And number 5 this time, the length of CD is not the mid-segment, CD is one of the bases. We're still going to use our formula. So first let's find the mid-segment. The mid-segment, MN, is going to be equal in length to 1/2 the sum of the two bases. So in this case, the length of CD plus the length of AB. Now I'm just going to go ahead and substitute the lengths I do know into my formula. So I know the length of the mid-segment MN is 1.8. I don't know the length of CD, that is what I'm trying to find. The length of AB is 0.6. So I need to solve this equation, I need to find the length of CD. So I need to get CD by itself. Notice I have some parentheses here. So I'm going to use the distributive property to distribute that 1/2. 1.8 equals 1/2 times CD is simply 1/2 CD. And 1/2 times 0.6 is 0.3. I'm going to continue to solve this to get CD by itself. I'm going to subtract 0.3 from both sides. When I do that, I get 1.5 equals 1/2 times CD. Now to undo this 1/2, to get rid of it, you can either multiply both sides by 2 or divide both sides by 1/2. You can type 1/2 on your calculator or you can use 0.5 if you want. So the length of CD, 1.5 divided by 1/2 gets me 3. And the length of CD is 3. And the very last one, number 6. We need to find the value of x. So we're going to be solving an equation. We know the mid-segment length and the length of the bases. So again, we're going to be using and setting up an equation using the mid-segment theorem. So my mid-segment is here. That length, 3x minus 2, must be equal to half the sum of the two bases. So it must be equal to 1/2 times the sum of the two bases, x plus 11 plus 3x plus 3. I'm going to simplify what's in parentheses here. X plus 3x is 4x. 11 plus 3 is 14. Now I'm going to go ahead and use that distributive property to get rid of the parentheses. 1/2 times 4x is 2x. 1/2 times 14 is 7. I notice I have x's on both sides. I need to move all my x's to one side. And then add 2 to both sides. When I do that, I see that x is equal to 9.